Hi guys, in this video I'm going to discuss program 10, how to execute program 10 and all, right? Most of you actually executed the program 10, right? So and also you people shared output with me. So those who have not shared output or executed the program 10, please execute it. Okay. So program 10 is uh, binary search algorithm, right? You're going to design, develop a code and run the program in any suitable language. So we preferably use C languages, C language, and binary search algorithm. And also we're going to test this one based on basis path testing, right? So regarding the program code, a simple program, how the binary search, right? Function is the binary search function, BINSRC, right? So which you're passing parameter that function, right? A simple binary search function, so binary search function, the logic, right? So linear, in the linear search, what you people are going to do. So in a set of function array, if array is there, array of elements is there, so people need to search the array for a key element. Okay, for example, if array contain 10 elements, right? For example, if the array contains 10 elements from 1 to 10, so if you need to search for a key, for example, say 3, right? In linear search, what you people need to do, from first element you're going to start the search. But in binary search, you directly go to the middle element. From the middle element, uh, middle element, first you need to search the middle element. You're comparing whether the middle element is the key or not. If it is the key, you will return success. Otherwise, you will search either a left or right based on the value of the key, right? If the key value is less than the middle element, you'll go to search in the left part. If the key value is greater than the key element, you're going to search for the right portion of the middle key. So if you want to perform uh, binary search, the one important thing is you need to give element in a ascending order from lower to higher element. It should be sorted. I mean, from ascending order you need to give element. Okay, that is the condition here, right? The common condition for binary search, right? So a function is there, right? Same way, if people can see here, right? Binary search functions. So if you want to, execution is same thing, right? Same thing, you are going to execute the program, and by first you need to save the elements in an array. Here the array is x, right? Some elements you're going to save that one. In that array you're going to search for particular key, right? So here, in this example, right? In this example, in this program, before going to conduct the path testing, one important thing you need to remember is, first just look for the function here, right? Just look for the function. In this case, the function is bin source. Just write the function with the line number, okay, line number of execution. So you followed same approach in program 9, where we conducted data flow testing approach, but we have actually numbered the line from first, first uh, first line to the last line. By complete program, we actually give a number for the program 9. But in program 10, just take the main function portion, just number it like this, right? This is actually the function with the line number. And see, this line number is according to the 1 2 3 4 5 6 7 8 9, right? Like this one only, we have given number to that one, right? according to the starting order only 1 2 3 4 5 6 7 8 9. You may have some confusion regarding the 8, right? Why actually we have 1 2 3 8 and that, right? Because 8, the return statement is there, right? In this program, this return occurred uh, two times here, right? Return mid as well as return -1. Usually return only occurs at last point of time, and I mean last it is considered as a last element of a last statement of a program, a last statement of a function. So here return -1, I am considering it as a 8, right? Last statement of a program. That's why, to avoid the duplication of return statement, I have given same number. I mean, in this program they have given they have actually given same number 8, as well as uh, for return -1 also 8, for return mid also 8. That is the only thing they have given. Rest of them is same thing, 1 2 3 4 5 6 7 8 9. And also you can observe here, for opening bracket with there is no line number is there, as well as for middle is equal to low plus high divided by 2 also there is no line number. Why? Because middle I have given already the line number in mid, so that is more than enough. No need to give line number for this one, right? So already I defined here mid here, right? So again there is no need to give line number for mid. And also for this statement also, for opening braces also, right? So this bracket, there is no need to give line number, only for closing point, because closing is considered as a separate statement, where opening this one bracket is not considered as a separate statement. So only you are going to give line number for the statement. Okay, so here also only for closing bracket I have given line number, for opening a bracket I have not given line numbers. Okay, that is one point you people can observe. Another thing is else part also, there is no line number for the else part here. Okay, only if statement is considered as a here the number, where else there is no line number for the else part. Okay, that is one point you people can remember, you people can consider. And also here it will always follows this always follows this approach, right? So coming to the execution and all, after execution you need to test, right? You need to test, you need to execute the test cases, uh, you need to write the test report. So how do you going to write the test case for this one? Here the approach you need to follow is basis path testing approach. What exactly this basis path testing approach? This is nothing but approach is there, that is called path testing. In the path testing this approach is there. So here in the path testing, say here for a common thing, here for example, here you consider this line number. See here, this is actually some example they have given this case for some program. This each statement is considered as a separate nodes A, B, C, D, E, F, G, H and I. So each statement is considered as a line number, and they have given node number A, B, C, something like this one, right? And also we have a separate path for that one, A, B, C first, A, B, C, E, F, G last, and also we have like that one we have 5 paths here, right? So if we apply the same approach to one of the problem, triangle problem, you can observe here in the triangle problem here in the triangle problem we have a path here, right? This path, it actually starts from line line number 4, since the first 3 is considered as a declaration. So we have only giving we have only start from the line number 4. This line number 4 is considered as a definition. Okay, output. First 3 declaration, there is no need to consider declaration. That's why 4, 5, 6 it's actually starting. Up to 4 to 8 it's a sequence, right? 4, there is no loop actually found here, right? 4, 5, 6, 7, 8. It is sequence statement. Only at the line number 9 we have a condition, loop condition, if condition. That's why at line number 9, based on the loop condition, the control goes either way, either go to 10 or 11. Okay, if this condition satisfy, it will go to 10. 10 in the sense is a triangle is equal to true condition will be satisfied, otherwise else part will go to 11. Else part is a triangle is equal to false condition will be satisfied. Again 12 in 12 condition, I mean 12 statement will come here, I mean in the if, and in the 13 also the loop condition. Okay, if is a triangle, what you're going to do, then you're going to execute the fourth statement. Again fourth is also considered as a loop. In this way we have different set of loop conditions here. Okay, here one approach you can write a DD path, decision to decision path. What exactly that DD path is? So you're going to replace the sequence with one node here. 4, 5, 6, 7, 8 is actually, if there is any sequence, you can just replace the sequence with one node, right? In this case, only I have one sequence. All are considered as a loop only, right? 9, 10, 11 is all are loop only. But 4, 5, 6, 7, 8 is a sequence, right? Sequence in the sense the program output is actually following in the sequential manner. After executing 4 only 5 will be executed, right? After executing 5 only 6 will be executed. In this way it will flow in a sequential manner. Okay, but coming to the 9, 10, 11, there is no sequence. According to the if condition only the program will execute. So if your program contains sequence, just replace the sequence with a one single node. For example, here I will give one simple example. Here this see here, in this case for DD path for triangle problem, 4, 5, 6, 7, 8 has been replaced with a DD path here, right? You can give a name. For example, you can give A, B, C, something like this, right? Rest of them are same because they have given here not much compression, because this example is controlled intensive. Okay, this triangle like example is mainly control incentive. Control incentive in the sense based on condition, right? There are many loops if conditions are there. Because of that one only we have one single compression we have made here. 4, 5, 6, 7, 8. That 4, 5, 6, 7, 8 is compressed to one single node. That is called DD path. Okay. So this is idea people should have before knowing about basis path testing. Path testing in the sense any program actually traverses a path here, right? Path testing in the sense what? Any program, okay, path derives from some graph construct. Okay, any program can be considered can be represented as a graph where each statement, for example printf statement is there, definition statement is there. Each definition, each different statements can be represented as a nodes in a graph, right? For example ABC or 1, 2, 3, 4, 5. You just give number to the line number to the program statement, and based on that line number, those line number is considered as a node, and we can construct a graph from that node. Okay, it's a basic idea of path testing. Okay, because this path testing is unnecessary. Why? Because when a test case executes, it traverses a path. Okay, when you actually execute a test cases, it normally traverses a path. Okay, either it will follow one path, first path, second path, third path. Either it will follow sequential path, or it will follow if condition or else condition. So in this way, different path you're going to follow. It is cache execution also. That's why we need to execute the path testing part here. But there is some problems are there. So let us discuss this problem later. But we should know this path testing definition as well as what exactly the basis path testing. So after knowing the path testing, and the variation or other version of path testing is there, that is called basis path testing. Okay, what exactly this basis path testing, that is also we are going to study, because that is the main idea of program 10, 11 as well as 12, right? So this basis path testing actually contains one important thing, that is called cyclomatic complexity. So based on that one, if you know the cyclomatic complexity of any code, okay, if you know the cyclomatic complexity of any code, actually, uh, you can easily solve the problem. Okay, you can easily solve the problem. Okay, this basis path testing is actually proposed by McCabe. It is also considered as a McCabe's basis path testing in 1982. Here, a vector space has a set of independent vectors called basis vectors. It's considered as a basis vectors are there, like 1 1 0 0 0 1 0 0 0 1, and for example, here, what exactly the cyclomatic complexity is? Simple thing. Formula is there. Vg is equal to E minus n plus 2p. Okay, that is the formula. Here, Vg, right? Vg is equal to Ca. Vg is equal to E minus n plus p or 2p. So why it is p or why it is 2p? We'll also going to discuss this thing. So E is nothing but edge. Okay, n is nothing but node, p is nothing but the program construct here. Okay, see here, p is either 1 or 2, that is the thing. Okay, for example, in this case, original graph, just count the edge here, 1 2 3 4 5 6 7 8 9 10 edges are there, right? This one, for example, this one is one edge, right? Right? A to B is one edge, A to AD is one edge, 2 is over, again 1 2 3 4 5 6 7 8 9 10, 10 edges are there. Nodes AB ED, that is 4 edge, AB ED and CGF. Yeah, so 4 plus 3 7 7 nodes are there. So in this case we have taken 2. Okay, if there is no connection between source to sink node, in this case source is nothing but the initial node, sink is nothing but the final node. If there is no connection between source to sink node, then the p you can consider you can give uh, p value as 1. So in this case 2p is considered. Otherwise, if there is, in the second case, just see here, there is a connection between G to A. That's why we have taken value of 2. We are only considering value of P is 1 only. Okay, that is the why is this? It actually means when there is a connection between final node to the initial node, it is considered as a strongly connected graph. Okay, that's why if you are actually uh, determining the cyclomatic complexity of any graph, always remember, if there is a connection between final node to initial node, the value of p is always 1, otherwise the value of p is 2. Okay, if there is a connection, then it is considered as a strongly connected graph. Okay, So this is a major idea here. Here, how do you why do we actually do conduct the test, right? So here in this case, for example, just see here one example is there. There are different nodes they have given, number of node also they have mentioned, 10 edges are there, and 7 nodes are there, right? 10 edges and 7 nodes. So this is one strongly connected graph, right? And also 10 e minus n, right? That is the formula, right? This is actually the formula here. E minus n plus p is the formula. So 11 minus 7 plus 1 is equal to 5. 5. Why it is 5? So before going to know what is actually this 5 means, this cyclomatic complexity is nothing but what the complexity to find a independent path in a graph. Okay, to find a independent path in a graph, we should know the cyclomatic complexity. That's what they have given here. The cyclomatic number of strongly connected related graph is the number of linearly independent cycles. So this is necessary because when there is a graph is there, if you execute the program, there may be number of different paths are there. Maybe different execution, if you test case may follow different path. But the thing is, it should contain some linearly dependent path. Then only we can differentiate the independent path with the dependent path. So that's why in cyclomatic complexity we are going to find the linearly independent cycle. Okay, that is the main agenda here, right? So to find the cyclomatic complexity, we use the formula Vg is equal to E minus n plus p. So for coming to the program here, just see this program. To find the cyclomatic complexity of this program, the same thing, the flow of execution will always start from 1, 2, 3, right? Easily you can based on that one you can use 1, 2, right? 2, this condition, just check 2 is actually while loop. So if it is false, it will directly go to 8. Return minus 1, it will return minus 1 will be returned. Otherwise it will follow the 3, right? If it is true, it will directly go to 3 node. Again 3 is a if condition. If it is true, what will happen? It will directly go to 8 and it will return the value middle element. Okay, it will return the value middle element. Okay, if it is false, then it will go for checking for if key is less than x of middle element. Okay, again there is another if condition is there. If key is less than x of middle element, it will go to 5th one, otherwise it will go to 6th one. Okay, easily you can construct this graph and independent path. You can easily check the independent path here. Since there is a connection between final node. Okay, in this case we have e minus n plus 2p. There is no connection between final node to initial node. I mean 9 to 1. There is no connection between 9 to 1. We are usually following the formula e minus n plus 2p. So 11 edges is there, 9 nodes are there. That's why it is 4 independent path we will get. What is those 4 independent path? 1, 2, 3, 8, 9. 1, 2, 3, 8, 9. 1, 2, 3, 4, 5, 7, 2. 1, 2, 3, 4, 5, 6, 7, 2. 1, 2, 8. These are all the independent paths. Only these paths are possible, right? You can check, for example. So how do you execute the case here? For example, for path 1, 1 2 3 8 9. See, just see here, 1 2 3 8 9. Right? 1 2 3 8 means what is 8? Why it is true? Only 1 2 3 8 only occurs when the searching key element is actually equal to the middle element. Then only it will go to true condition, right? That's why the middle element you directly give here input. You can give 30 as a input middle element, right? And success will be returned. What is 1 2 3 4 5 7 2? Just check. 1 2 3 4. 4 in the sense x is equal, key is equal to x. X of middle will be false, and 4 1 2 3 4 1 2 3 4 5 7 8. Only 5 is occurred when key searching key is actually less than middle element. That's why you should give a less than 30 number. For example, 10 10 20 30. In this case 30 is the middle number. You should give less than 30 value here. I have given 20. That's why repeat and success should be output. The same way, 1 2 3 4 4 6 7 2. 1 2 3 4 6. Only you need to follow, only you can come to 6 only if the key element is actually greater than the middle element. That's why you should give more than 30 for this one. I have given 40, so repeat will 6 will be repeated. And the same way 1 to 8 9. Just observe 1 to 8. Only it will go to 8 if the condition is actually false, right? What is the second condition here? While low is less than is equal to high should be false. That's why I have given 60 or 5. If it's 60 means it is greater than high, then 5 means it's less than low. Okay, that's why repeat and failure will be the answer. 1 to 8 9. Again I have given fifth path for 1 to 8 9 here, right? Same path, any key you can give for failure. Okay, so in this way actually you can execute the test case, right? This is for program 10. Easy. First construct the program function, give line number 1 2 3 4 5 6 7 8 9 up to the 1. Since return element is repeated 2 times, I have given 8 to both the return statement. There is no line number for opening bracket, only give line number for closing bracket. That is one point you should remember. And you can write the graph here 1 2 3 easily. You can construct that one according to the formula. Vg is equal to e minus n plus 2p. E is edge, n is nodes. Since there is no connection between at the final node 9 to the initial node 1, the formula is actually e minus n plus 2p. If there is a connection between 9 to 1, then the formula is e minus n plus p only. Okay, so I just mentioned the independent path 1 2 3 8 9. Independent path is nothing but there is no dependency between these 4 paths, right? There is no dependency. There is no P1 P2s are actually separate. P1 P3 is separate. P1 P4 are separate. There is no dependency between this path. So why we need this independent path means, if you want to execute test case for all the path, there is a lot of time should be lot of time actually consumed. To avoid that one, you are actually finding the independent path. For that independent path only you are going to execute test cases. If you execute test cases for the independent path, you will actually covering all the aspect of the test cases. So it is very important to find the independent path and execute the test cases for that independent path, so that you can cover all the aspect of test case execution. Thank you. If you have any doubt, please let me know regarding this one. So once the college reopens, I will again explain this path testing and all. Okay, not only path testing, all the concept I will explain. So if you have any doubts regarding this program 10, please let me know. Okay, I will clarify your doubt. So thank you very much.